Hello students, I hope you are all doing well. Welcome to today's session where we are going to dive into a fundamental concept in mathematics, which is sets. So this concept forms a base of for many other topics such as sequences, probability, and many others. So it's a very important topic. The theory of set was first formalized by the German mathematician named George Cantor. And since then, it became a crucial part of modern mathematics. Now, you might be wondering, what is a set? So let's start something that you already know. Imagine your wardrobe at home. In your wardrobe, you have shirts, pants, shoes, etc. So each of these can be thought of as a set of items. For example, your set of shirt, your set of shirt. So this might include a red shirt, a white shirt, a blue shirt, or whatever you have. Similarly, your set of pants, your set of shoes. So in mathematics, we group objects or elements into sets based on a specific rule. So to understand it more, let's take some more example. Can you think of any other example of set? Have you heard of the term set before? You must have, right? For instance, you might have heard of a set of cups, right? Sets of cups or set of glasses in your home, right? So these are practical examples where items are grouped together based on a common characteristic. In a set, all the members should have a common characteristic. For example, if you have a set of cups, you cannot put a spoon in this set. Okay? You cannot put a spoon in this set. You can only put cups in this set. I am talking about sets of cup in your house. Okay? So the idea is that only items with a similar characteristic are grouped together. So in a set, what we do, we collect in a set, in a set, we collect items that share a common characteristic or type. So what do we do in set? In set, we collect items that share common characteristic or type. For example, in the set of cup, all the items are cup because they share the same characteristic that they are all cup. So this idea of grouping based on shared trait is fundamental to the concept of sets in mathematics. So let's see what is a set in mathematics. In mathematics also, we come across collection. For example, we come across natural numbers, points, prime number, etc. So let's examine the following collection. Odd numbers, odd natural numbers less than 10. So what could it be? 1, 3, 5, 7 and 9. The rivers of India. The vowels in the English alphabet. So what would that be? A, E, I, O, U. That's it. Various kind of triangles. Prime factor of 210. So that would be 2, 3, 5 and 7. The solution of the equation x square minus 5x plus 6 is equal to 0. So that the solution will be x is equal to 2 and x is equal to 3. Note that each of these collections are well defined. What does it mean when I say each of these collections are well defined? So well defined means you can tell whether something is member of a set or not. What does well defined means? It means that you can clearly tell if something is member of the set or not. For example, we can say that the river Nile does not belongs to the rivers of India because it is not a river of India. Whereas the river Ganga belongs to the collection, the river of India. Similarly, you can say that B does not belongs to the vowels, the set of vowels in the English alphabet because it is not a vowel. Similarly, a square does not belong to this set. So we can clearly tell if something is member of the set or not, right? For all of these things. So it is a very important property of set. It tells you whether a collection is a set or not. Okay. So to form a set, what do we need? We need a collection that is well defined and it should also be distinct. So to form a set, you need a collection that is distinct and well defined. So you will not write it like this. For example, odd natural number less than 10. You will not like it like this. 1, 1, 3, 5, 7, 9, 3, 9. You will not write it like this. You will write 1, 3, 5, 7 or 9. Okay? So this is how you will write. Now let's see a formal definition of set. A set is a well-defined collection of distinct objects. So you need two things, well-defined and distinct. The collection should be well-defined and distinct. Can we think of an example that is not a set? Think about like this. The set of good, the set of tall students in your class. Unless and until you define what does tall means, what does tall students mean, it is not a well-defined set. Because suppose you have Amit and his height is 5 feet 10 inch. For some people, it could be that he is tall. So suppose if you have a student named George, whose height is 5 feet 6 inch. For George, Amit is tall. But suppose you have John, whose height is 6 feet 2 inch. For John, he is not that tall. So if John would make the set, he would not consider Amit as he may not consider Amit as tall student, and he may or may not put him in the set. And John might be consider him as tall student because he is tall. Amit is taller than George. So he will put them in set. So tall student is not a well-defined thing. But if you write this example as the set of all students whose height is greater than 5 feet 8 inch, and they will consider as tall students. So you have defined this meaning tall here. Okay, then you can easily measure the height of each student, and you can tell if someone belongs to this set or not. So that set should be well defined. Now, even if you have 2 John in your class, suppose you take this set, the well defined one. So even if you have 2 John in your class, suppose you have John 1 and John 2. Okay, they are same. The name are same, John and John, and both of their heights are over 5 feet 8 inch. Then when you form the set, you can write it as John, because you know that these 2 John are distinct. Okay, so only in these conditions you can write your John twice, when these 2 Johns are distinct, they are not same. Okay, so 2 things should be satisfied to form a set. It should be a collection that is well defined. By well defined, I mean that there should be no doubt that whether something or someone belongs to the set or not, and the collection should be distinct. So this is the mathematical definition of the set. In the next video, we'll see the representation of sets and some notations related to sets. Thank you for watching.